All right. Thank you, Sarah. So I will restart from scratch. So the thing is, the first thing that we're going to do is collect the data. We're going to collect data from the Discourse Hub community forum. So before I say why we're going to, like scrape data from the Discourse Hub community forum, let's say first what we're trying to build. So what we want to do is to build a forum post classifier. So let's say, for example, someone will give you their text. Let's say, for example, they will write a bunch of text, and you will help them figure out which category that post will fall into from a certain given forum. That is, for example, scrape only one forum. If, for example, you want to build a forum post classifier, as in not category, but more like the forum, like for example, someone will give you a certain post and you can tell them which forum it is, then you will have to change the classifier, the target, into forum and not the category. But normally this is built to, like this whole project is to build a category forum post classifier. But if you want to change the end goal, you can do that. It's going to be the same anyway. All right, so this is the goal. So first things first, we're going to collect data from Discourse Hub community forum. So when you're picking the Discourse Hub community forum or communities, make sure you remember that you need a forum that has high activity, that at least medium. It doesn't have to be high, because if it's high, then you may fall into the problem where you have lots of data and you have to only to collect some. So medium is good. And it's best if the language used is English. This does not mean that you should limit yourself to English, but just that remember that machine learning algorithms, most of them are actually trained on English data, English language data. That's why it's better to pick an English forum. But if you want, for example, to pick, for example, a German forum or anything like that, of course, you can translate the data or even just go around and see if there is some kind of pre-trained model that you can use. This is just a general highlight. So second thing we're going to do after getting that data is exploring the data. It's called exploratory data analysis, normally, in technical terms. What you're doing practically is just checking how the data is, like the quality of your data. Try to find out if there are any kind of outliers, any kind of noise that you want to remove from your data, so that your models, so that you can make it easier for your models to interpret that data. Remember that machine learning is just having certain concepts or data and trying to model it so we can understand how reality is, like mathematically represent that reality. This is what machine learning is all about. Great. So after exploring our data, try to draw out insights from it. Apart from cleaning it, you will have to draw some visualizations to try to understand, like for example, let's say, what is the most popular post, or who's the, who's the most active user, or what's the most popular category, or something like that. Try to answer different questions as they come to you. So the second thing normally is going to be training machine learning models. But because we want you to try, and get a feeling around how you can build a recommender system, we very shortly highlight a very short example of a very simple recommender system that you will build using using the content-based method from the recommender systems. And it's going to be like just calculating similarity using the COSIN method. There are other methods you can try as well, and you will find all the details in the module that has this. I will go over the module that are available shortly. So after building this very simple recommender system, which you can use in the final stage. If that is, like what you think will be best, you will be doing we'll be choosing what is the best solution to deploy. So second thing is going to be training your machine learning models. So at first we will be we'll be training very simple models, because usually when you're actually trying to model a project, you don't go around trying those deep learning, difficult, high-level models or state-of-the-art models. Because most of the time, these state-of-the-art models can be an overkill, especially if the problem is very simple and can be just modeled using logistic regression or linear regression most of the time. So there's no need to go around trying those difficult models. Always start with very simple models like logistic regression, SVM. And if you want something more sophisticated, you can try ensemble models like, for example, random forest, XGBoost. And if it doesn't work, or if you think the actual problem is very far from all of these, like your models can't really model it, you can go around trying deep learning models like BERT, for example, Roberta in our case. So this is what you're going to do. You're going to first train very simple models. You will train very complicated models while dealing with some problems that you will encounter in the middle when you're modeling. After that, you will choose the best model between both of these. Remember that when we talk about the best, it's not always about the performance. Sometimes it's about, for example, the time it's running. Like, for example, the model A takes 10 seconds to run. Model B takes only 1 second to run, for example. You may want in real life to choose the model that runs only for 1 second, even though its performance is not perfect, but it's still acceptable. And because, for example, in your business, or the stakeholders are more interested in something that can run faster than something that really gives you something, like the exact prediction. So it's going to all depend on the choices you're going to make. Just make sure when you're actually making a choice, say why you choose whatever you choose, because that's important. We don't choose things blindly. We need to always make sure that we're telling people why we are choosing something over something else. All right, so after that, we will build a simple web app using either Flask or Streamlit. You can use Fast API, you can use Django, you can use whatever you're comfortable with. Otherwise, you can just go with the tutorials that are available and start with that, and you can build upon it. Then you can deploy your web app using either AWS or Heroku or some other service. There are lots and lots and lots of them out there online. So again, if you choose something else, please make sure that you're argumenting why you choose whatever you choose. All right, let me just step out from this and show you the project in the Stacker app. All right, so usually when you get started, you have this summary to talk. Let me just get started from the start so I can show it to you. So this is, for example, my profile. I'm going to go to summer 2021 projects, choose the pathway. So for me, it's going to be machine learning. Okay, and I'm going to choose NLP-based post-classifier recommender system, because this is, the project I'm explaining right now, definitely. And under this, you have project content, the problem statement I just explained. Then you have all kinds of details, like, for example, tools, libraries you're going to use, technical skills you're going to gain, soft skills you're going to gain, and some badges you can, pick up along the way. All right, so the project modules are The first one is getting started. This one just has lots of resources you can go over, especially if you have never had the chance to try machine learning or NLP. And of course, for people that are interested in project management tools, which you will need usually in the industry. So there are provided links as well, so you can get started with them. So after that, we need to gather data and preprocess it. So that's the second module. Third module is exploratory data analysis, cleaning your data and understanding your data. Then we have basic recommender and simple classifiers. So this one is going to be about, how you can build your basic recommender, the one where you will use the cost and similarity to recommend posts. And then this one is going to be about simple classifiers, like simple machine learning models, like I told you, logistic regression, or even ensemble models. In advanced modeling, you will find the deep learning models that are used in NLP, state-of-the-art ones like BERT, NLP, Roberta, and all of the state-of-the-art ones. And of course, at the end, you will have to put all of this together and build your web app and deploy it. So there are actually some project challenges you can try if you find, let's say, for example, of this, you already got familiar or, you finished this app quite quickly. You can go around and try to improve your project or even write about it. Remember, you can improve every step of the way. So before I move on to the next step, can someone tell me like what kind of challenges you think you may fall into for this kind of project? And there are lots of challenges you will come across around. So anyone would like to step out and tell me what kind of challenges you think you may encounter in this kind of project? Anyone? Or would you like me to pick someone?
I think it's gathering data.
Gathering data. All right. Like what? Like specifically what?
There is not much of data that we can gathering, so which makes the next step analyze data might be a little bit difficult because we don't have enough data to train the model.
Okay. So to avoid this kind of problem, you have high activity forums. So you can just avoid the forums that have low activity, or you can scrape several low activity forums that are similar to each other. So you can mix up their data to build one data set. But that is quite something that is relevant. There is another problem that you will fall into that is still in this kind of data, but it's not about data gathering. I don't want to give away the word, but I think you may have, got a hint. It's usually a problem that you find everywhere in machine learning or even deep learning. Anyone?
Some sort of data overflow, maybe.
Overflow?
When we have a lot of data and it becomes harder for us to train our models based on data.
Not really. I think machine learning people are always happy to get more data. This is something that they will never be upset about. So I think it's the other way around. So for example, you're actually scraping categories, for example. You're scraping very specific topics for categories. So the thing you encounter most of the time, all the machine learning projects suffers from this, which is class imbalance. So say, for example, you'll find out some categories have more topics because they are popular, for example. Some categories will have very, very few topics, like only one or two. And that is a huge class imbalance, right? Is this clear, or should I explain it in a simpler way? If you don't talk to me, I won't know what is happening.
Yeah, it's clear.
That's good. All right. So I will go back to these challenges later on and ask you again. So please think about it while I am going through this. So usually a typical machine learning project, what we have is that we first define the actual problem that we want to work on. So for example, here, what we want to do is build the forum post classifier. So we know what we want to do. But in real world cases, you will most likely have to define the business problem. So this is the first step that comes. Here it's already defined for you, but even then you may want to get even more, like define even the small details, but that usually comes along the way. So the first thing we do is define the business problem, what we want to solve, or what is it that we are trying to solve, or what is it that we want our model, machine learning model to do. After figuring that out, we of course need to get the data to answer that question. So we get that data. Data from the real world is always messy, dirty, there are missing values, there are outliers, so sometimes like there is class imbalance, like you want, for example, some categories have more data, some others don't even have that much data, like just one. That's not even worth mentioning. So we'll have to deal with these kind of things. And all of these are just decisions you will have to take, and they will kind of either improve your performance or drop the performance of your model. So the second thing is that after this, of course, you will have a good prepared data. After you have exported it, cleaned it, perhaps you will do some feature engineering. Like, for example, you will add some features, you will drop some other features. After all of this, you will, of course, call out the machine learning algorithms and feed this data to them. Then they will learn from that data. And after that, usually what we do, we train several machine learning models, especially if it's very simple models. That's what we do. We train lots of machine learning models. Like, for example, it depends on people. There are some who train 4, others train 5, like in parallel. After training several models, you will have to pick the best model from those that you have. Of course, depending on some parameters. There are performance metrics, but then even performance metrics depend on the business problem that you have. So you have to be very careful about that. And of course, after that, you will, like you found out the best model, everything is working out, your model is performing well. Now is the time to deploy what you have built so far. So you get that model, put it in an app, and then of course you will deploy it. And after that, you will have to monitor it and update it, of course, across time. So the thing is, this process, I just want to say that this process is not linear. So at any given time, you may have to go back and redo a certain task because, like usually what we do in real world is that we go around trying, like, let's say, for example, we know what we want, like we have a feeling of what we want to solve, and we go around trying a very simple model, train it just to get around the feel, like how is the model behaving with this data. And after we have figured out, like, just to get a hunch of how everything is working, then we go back and redo everything. Like, we redefine properly the business question or the problem that we want to solve. We do very heavy exploratory data analysis and cleaning of data and feature engineering. Then, of course, we try some really good models, and of course, we fine-tune them to get the best model. Then, of course, we deploy into the app. Great. Now, what is the difference between a typical machine learning workflow and an NLP project workflow? The only difference is that in NLP, we have text. We're dealing with textual data. So with textual data, there comes a very specific way to pre-process this data, like, for example, tokenization, removing stop words, stemming, normalization. Sometimes you may want to not do this kind of pre-processing because it's going to affect the performance of your model. Sometimes this pre-processing can actually improve the performance of your model. So again, you will have to take these kind of decisions. Then of course you will get your pre-processed data, you will feed it to a feature structure. So most of the time, this kind of feature structure are going to be the ones that will transform our text into actual numbers. Remember, computers don't understand text. They only understand 1 and zeros and usually, of course, now numbers. So we get all of those into meaningful numbers, what we call embeddings. And then of course, we're going to feed whatever we did to a model and, like do the same as the previous workflow. Sorry. Oh, yes. Any of these schemas, you can actually just click on them to get them. And if you want me to share the slides, I mean, if you're interested in them, I can share them with you. So now, after we have talked about the machine learning project, we need to talk about how we can collaborate between different people, our teammates, for example, people we are working with. So there are several ways we can collaborate with people, and GitHub and Git is just one of them. So how does GitHub, how is a typical workflow of a GitHub project is? So usually in a huge, let's say, for example, you have a huge project. So what we do is that, for example, we create features, because usually, let's say, for example, you have an app. Usually there is a signing in, sign up. There is, home page. There are several specific features you want to add. Let's say, for example, even the add to cart, for example, for e-commerce websites or applications, that's a feature. So they code every feature alone, of course, so we can finish up quickly. People need to do parallelized work, distributed work. So all of us code all of this, and at the end, we will gather all of that into one package and deploy it, which is one web app, for example, or one mobile app, something else. So the thing is, the feature is called as a branch. So one thing to note is that GitHub got rid of master, and now we have main instead of master. So usually you create branches, and each branch is going to be for something specific, a task, for example. And then when you're coding that branch, like when you're coding that feature, let's say, for example, you're working on a specific model. I'm working, for example, on logistic regression, or for example, I'm working on EDA. I'm going to create EDA as a branch. I'm going to create logistic regression as a branch. I'm just giving an example. And then later on, I'm going to say, hey guys, so I actually fixed it, like I developed this machine learning model. Can you check it out for me? So for them to check this out for you, you need to commit the changes you made and submit the pull request. The people in your team are going to check out what you did, fellow machine learning engineers or machine learning scientists. And then after discussing what you did, if they find out it fits well, it does whatever they need it to do, then they're going to push it to production. So master or main, previously called master, is actually the final product, the one that your users are going to use, or the one that is going to be deployed, for example, in another software solution or anything like that. Any questions in here before I move on? No? Okay. So now, GitHub was actually for coding. Now, how are we going to communicate between humans, define tasks and know what has been done, what should be done, what kind of problems we encountered even, and how can we solve stuff? So to do that, for example, we can use Trello. There are a bunch of other tools you can use as well. But for now, we're going to use Trello. And you can define it as simply as provided here. Like you have a to-do list, you have doing, and then you have done. So you can tag people, assign people to a specific task, move a certain task from different stages, like to do, to doing, and then done. And yeah, you can add several things. Like, for example, you can add a card called errors, or, you know, like troubleshooting or something like that. So this is how we communicate with people usually without needing to always meet them face to face or even online. But meetings are important though, to communicate. All right, so let me just show you an example of the, you know, of the web scraping from my team. So it's from Team for Machine Learning June 2020 session, and this is the my sitemap that one of the teams put out there for us to understand the structure of the Flowster discourse forum. So when you're web scraping, before you start web scraping, you need to understand the architecture of whatever you're trying to scrape. You know, for example, here, a website, the Flowster discourse forum. So we need to understand this architecture so we can make it easier on ourselves to scrape. If you understand the architecture, is going to be easier to scrape. And, you know, like, for example, if you can even specifically find out that, you know, like mention, for example, here, the HTML code that you need to target. For example, sometimes you will find some properties, you will find some IDs. If you can, you know, add them here, it will be easier for the person that is going to scrape to scrape quite quickly, because they know what is happening in the website. They know, for example, if they need something specific, what to look out for in the HTML code they will be scraping. Well, that's it. So do you have any questions? No? Okay. Yes.
Can you share the can you share the link to the slides?
Yes, I can share the slides with you.
Okay, that's cool.
Where can we find the recording?
Oh, I will share it somewhere and share it with Sarah. Let me see if Sarah is still here. Okay, Sarah isn't here, but I will share it with Sarah, and normally Sarah is going to share it with you in the forum. You will find every kind of resource you need, you will find it in the forum. All right.
I have a quick question.
Please go ahead. Please go ahead.
How do we communicate with other team member? Just post them in the SteamAway website, post something.
Sorry, I didn't get your question. Can you please repeat it?
Yeah. How can we communicate with other team members?
Okay. So with other team members inside the forum, right?
Yeah.
So usually, let me just show this to you. Okay, let me open the STEMaway forum. So if you're part of the teams,
yeah,
you'll be having your own private channel. So let's say, for example, let me just give you an example by using a post of the posts that we have. Can you just find it out? Use machine learning. Where's Pathway? This one. So let's say, for example, you want to communicate with me, just an example. You will be going ahead and, you know, like reply to a certain post, or even you can create your own post, you know, about a certain issue or something like that, and tag me, for example. Okay, I can't be tagged because it's me. But for example, if I want to tag Debelina to talk to her, I would just use her, you know, her username, and then write whatever I want to write to her, and she will get that message. She will get it here. She can find all of these here. or you can message people directly, privately. But if you want it to be open, like, you know, everyone, you want everyone to see it, you can just tag her in a specific post, for forum post, or you can create your own forum post if it's, you know, a new issue, or you just want to communicate, you can do that as well. But you will be, I think they will be creating Slack for you, Slack workspaces for you to communicate as well. But in the forum, you can just tag people and directly tell them whatever you want to tell them. I wish I could show you, like, for example, you can see these kind of examples. So all of these people, for example, are communicating between each other on the forum. And if you're part of a team, you'll have your own workspace. So no one can check out your workspace. So you can communicate between your teammates freely. Did I answer your question?
Yeah, thank you so much.
You are welcome. It's my pleasure. Any other question you would like me to answer about the project? Or it's pretty clear?
Hello?
Hello?
Yes, I have an open question. Like, if for example, I have a problem of, I need to build a recommendation system using NLP. So most of the time also we have a different kind of method that instead of using NLP, we are using some other artificial intelligence technique like reinforcement learning. I saw in the internet something like you can build reinforcement learning recommendation system algorithm using reinforcement learning. So I would like to know if you have some insight about the difference between building recommendation system using NLP and reinforcement learning.
So actually what you're doing is that you're using deep learning in general to build a recommender system, because a recommender system can either be built using normal ways, you know, for example, here in this project, you will be using a very simple trick, which is called calculate for, you know, just going to use similarity. But in advanced settings, you may want to use deep learning models. It can be an NLP deep learning model, like BERT, for example, or it can be, like you said, reinforcement learning. The difference is how, you know, like, it's what do you want to build? Let's say, for example, perhaps you already know this, but for reinforcement learning, why do we use it is when we want the model to learn by itself, by, you know, to learn from its own mistakes. It's like you're doing active learning, like I explained in the beginning of the session, if you were there. It's something similar to active learning, because at the end, the model is learning by itself. It's like, for example, it's making its own mistakes, it's taking its own decision, and it's learning from these decisions it is taking. That's what is reinforcement learning. But in deep learning models, the normal ones, you know, after they have been trained, they don't learn later on. They don't learn the new patterns from new data. You see, because the only way for them to learn the new patterns is by you retraining on the new data. But reinforcement learning, it's active learning. It's like humans, kind of, if you got my point.
So to build a reinforcement recommendation system based reinforcement learning, do I need a kind of data set to do that? Because in reinforcement learning, we don't usually need data to train our model. As you said,
in all the AI practices, you need data. In all AI algorithms need data. That is a basic thing. The problem is specific data to your problem. So for example, reinforcement learning, we need a very specific kind of data. Like, for example, you have to frame your data to, you know, to be what it should be for the reinforcement learning task. Like, for example, just an example, in reinforcement learning, usually we have action items. I believe there is the reward system, and there is another system. I don't remember what is the third one, but they're usually, I believe, either 4 or 3. That
Yeah,
each of these components.
Yeah. I don't want this meeting to be oriented into reinforcement learning. So I wanted just to make a difference between recommendation system based on NLP and reinforcement. But I understand now.
Yeah.
It's
So
fine.
yeah, it depends on, yeah, at the end of the day, what it's not, it's do not stick yourself to the technique. Stick yourself to what you want to build, and use the technique to fit what you want to do. That is what I want you to learn.
Yes, exactly. Perfect.
Yeah, you use the right tools to solve your problem, and do not worry about the tools.
Yeah. Thank you.
You're welcome. Any further suggestion or we're discussing, I mean. No? Okay, I'm going to ask you the question I asked you before. So what kind of challenges do you think you will fall into? So we already said class imbalance problem, data problem, the lack of data. What kind of problem can you face again in this project? So one of the things that you should learn what to do is to figure out, I think this is something that you will pick by doing several projects later on. So you will learn what kind of problems you may face from the start. So usual problems we face in machine learning is the data that we have is garbage, complete garbage. So the theory says garbage in, garbage out. So data quality is very important. So whatever data you're going to choose, it needs to be in a good quality. Another problem that we face is a class imbalance problem. And another problem that we may face is that the model that we choose does not fit into the app, for example, that like into like the device we want to deploy it on, especially for people that use edge devices, the small tiny devices like Raspberry Pi and all of that. So the model does not fit there. And usually if the model does not fit there, we have to go back to a very simple machine learning model and forget about state-of-the-art model. So these are, like some of the problems that we face along the way.
Can we say also like user preference is should be a problem in recommendation system? Because I can prefer user preference. User preference.
Yeah,
like,
of course,
example,
of course. Yeah. Of course, it's a parameter. So in recommender systems, there is something called collaborative filtering and there is content-based filtering. So there are these two main ones. And under these main approaches, there are techniques that you can use for either of these approaches. And there is a third approach that combines both of them, the best of both of these words to get the best solution. So there are lots and lots of theories and of course practices in recommendation systems. And there are still lots of problems that we still haven't found out the solution for recommender systems and all the NLP or any kind of AI problem. We're still in the development phase. So there are lots of problems that you will face, but you just need to get used, to overcoming them. And of course, there are several techniques that gets updated every day. As you can see, research is pretty active in the field. All right. Anything you would like to add? No? So we still have 3 minutes to go, and I would like to ask one of you. So, did any of you build, any machine learning app? I'm talking about something that has gone to being used by other people. Or what are the, like, what is something funny or crazy you built using ML or AI in general, if there is any? Anyone? Anyone?
So I can talk to myself because
Mhm.
I'm a member of the Intelligent Robot Learning Lab in Alberta University in Canada, but actually I'm in New York, so I'm working remotely. So
Mhm.
I built an algorithm, name it COAS, Conversion Actor Critic by Human Feedback, which is
Mhm.
an algorithm that can teach a robot to accomplish some kind of task. So for example, a robot can do some task, and then the human is watching the robot making some action. And if the robot is making the wrong action, the human is punishing the robot, like giving -1 or saying it's a bad task. If the robot is doing some kind of good things, the human is giving him +1 or good as a signal.
I see.
So the robot
Is
is receiving the signal from the human, and as we go, the robot is learning from the human. It's
is
kind
your
of a
domain?
human.
Yeah.
Hmm?
Is your domain knowledge reinforcement learning? Like, is it
Yes,
the?
yes,
I
yes.
see.
This is mine. I'm mostly
That's
interested about.
interesting. Yeah, it's
Yeah,
an
human.
interesting application.
Okay.
Thank you for sharing it with us. Like, what kind of challenges did you face during the creation of this solution?
Oh, the main challenge that I faced was when I was working on this project, I was in Africa. So, in Africa, it's not the main challenge is the internet. You need to
Yeah.
build your model. You need to build your model and train it online for like 2 days, and then if you don't have enough source on Google Cloud or or AWS, your model will shut down and you need to restart it again. So
True.
that was the first challenge, and the second challenge is a lack of mentor that can help me if I get stuck somewhere on my algorithm to help me to debug my algorithm. That was most of the time the two main challenge that I faced when I was working on this project.
That is interesting. Those are usually the main
Yeah,
challenges we have in Africa, like you said.
yeah, I can even share it, so it's open source. No one is interested can check it.
Thank you.
Yeah,
Thank you.
yeah.
I'm definitely gonna check it out. Thank you for sharing this with us. That's amazing. That's pretty amazing. All right. So thank you everyone for coming, and I hope you enjoyed this session and you learned something new. Hopefully you did. Otherwise, I hope to see you in the next session. Thank you everyone. It was nice to meet all of you and get to know all of you.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you everyone.
Thank you.